Okay, so now that you know how to solve a 2 by 2 system of equations, we're going to use what we learned to solve a 3 by 3. So a 2 by 2 system is a system of two equations with only two variables. But a 3 by 3 system is a system of three equations with three variables. So that's what we have here. So the idea with a 3 by 3 system is to get rid of an equation and get rid of a variable so that what you end up with is a 2 by 2, and then you can use the techniques that you already know for a 2 by 2 system. The techniques were substitution and elimination. So how do we go from three equations to two equations and from three variables to two variables? Well, what we do is we start with two of these equations and see if there's a way to combine them to get rid of one of the variables. And if you notice, look at the first two, the first equation and the second equation here. The first equation has minus y, and the second equation has a plus y. And so we can see that if we add those two equations together, we might be able to eliminate y and end up with a single equation with just an x and a z. So let's do that and see what happens. So let's take the first two equations and just rewrite them. So the first equation is x minus y plus 3z equals negative 3. The second one is negative 2x plus y minus 2z equals 8. And now let's see, add them together. So x minus 2x is negative x, negative y plus y is 0y, and 3z minus 2z is z, and negative 3 plus 8 is 5. So let's just rewrite that. We can see that 0 times y is just 0, so we can rewrite that as negative x plus z equals 5. All right, so now what do we do with that? Well, what we need to do is get another equation out of that system, the original system of three equations. Get another equation that just has an x and a z in it. So let's go back to the original three and see if we can take a different pair of equations. So we already used the first and the second, so now we can either use the first and the third or the second and the third to eliminate the same variable. We don't want to eliminate x, we don't want to eliminate z, we need to eliminate y. So we'll have two equations in the same two variables. So it looks like if I take the first equation and I multiply it by 3, I'll be able to add that to the last equation and also get rid of the y variable. So let's see what that looks like. Let's rewrite that. So that equation becomes 3x minus 3y plus 9z equals negative 9. And now let's take the third equation and just rewrite it right below this one. Negative x plus 3y minus 4z equals 6. And if we add them together, 3x minus x is 2x, negative 3y plus 3y is 0y, and 9z minus 4z is 5z, and negative 9 plus 6 is negative 3. So we got rid of the y variable, which is great. That's exactly what we needed to do. So now let's take that equation and rewrite it below the other equation that we just found. 2x plus 5z equals negative 3. So this is our new system. We've taken a 3 by 3 system and we've reduced it using elimination. We've reduced it to a 2 by 2. And so now we can either use substitution or elimination to solve this system. Once we solve this system, we'll have a solution for x and z, but we need to remember that we're looking also for y. So we'll have to take those two numbers that we get and go back to one of the original equations to find y. Okay, so how do we solve this system? Well, there's a bunch of different ways to go, but it looks like I can take that first equation, multiply it by 2, and when I do that, I get negative 2x plus 2z equals 10. And if I write the second equation right below that and add them together, I've gotten rid of the x. So I get 7z equals 7. 7z equals 7. Divide both sides by 7. And I wind up with z equals 1. And now, remember, we have to go back to one of the two equations that we had, take that number for z, and plug it into one of the equations to get x. So I'm going to take that first equation. It doesn't matter which one you choose. And I get negative x plus 1 equals 5. And if I subtract 1 from both sides, I get negative x equals positive 4. So now all I have to do is multiply both sides by negative 1, and I get positive x equals negative 4. So I've found x. And so now I've got z, I've got x, and I still have to go back and find y. So I go all the way back to the original three equations, and I just have to choose one of them. Doesn't matter which one. So I'm going to take that third one, and I plug in negative 4 for x, and I plug in 1 for z. And let me rewrite that. I get positive 4 plus 3y minus 4 equals 6. Positive 4 minus 4 is nothing, so that's really just 3y equals 6. Divide by 3 on both sides, and I get y equals 2. So there's my solution. X equals negative 4, y equals 2, and z equals 1. So the key is to use a pair of the equations to eliminate a variable, then go back and use a different pair to eliminate the same variable, and you end up with a 2x2 system that you can solve. Then you use the solution to the 2x2 system to go back and find that third variable. Okay, so good luck with these, and let me know if you have any questions.